1. Okay, so we're about to get started in our fraction unit. So before we do, we're going to talk about factors and multiples. We're going to focus just on factors and multiples today. They are important because we are going to learn about least common multiple tomorrow and greatest common factor tomorrow, and both of those help us in our fraction unit. So when we are trying to reduce fractions or simplify fractions, we do that by using the greatest common factor in order to reduce. You're going to see some examples of that tomorrow. Least common multiple is important when we start adding and subtracting fractions when our denominators do not match. So you've got to know how to do both of those things, which is why we're starting our fraction unit with something that seems maybe kind of weird, but it actually has a lot to do with fractions. And you'll see that more as we start doing more and more with fractions, with simplifying and also writing equivalent fractions too. You have to know both of those. So we're starting out very simple, just factors, just multiples today. We're going to practice identifying factors and multiples. Tomorrow, I will introduce you to least common multiple, greatest common factor. So that'll be tomorrow. I was going to try and do it all in one day, but I think it's just too much. So starting out, we're going to identify what a factor is. A factor is the number that you multiply to get a product. So a factor, that is a number that you multiply to get a product. So my factors of 12 would be the numbers that I multiply that equal 12. Like 1 is a factor of 12, and 12 is a factor of 12. 2 and 6, 3 and 4. Those all can be multiplied by another number to equal 12. So those are called factors. Okay, multiples. Multiples are the product. Remember, the product is an answer to a multiplication problem. It's the product of a number times any whole number other than 0. So multiple is the product of any number times another number other than 0, because what is the product of any number times 0? It's always what? 0. So a multiple is the product of a number, say it's 1, times any other number. So I could say 1 times 9. My multiple is 9. Well, 9 times 2 gives me 18. 9 times 3 is 27. 9 times 4 is 36. So 9, 18, 27, 36, 45, 54. Those are all called multiples. Okay? Common. You're going to hear me say the word common a lot over the next few weeks. Common means shared or the same as another. You're going to hear this a lot over the next few weeks. Common means shared or same as another. Multiples. The thing about multiples to help you keep it differentiated between multiples and factors, because that's where we get confused a lot, even because I did this already in my other math class. So what I noticed a lot of, and what I've always noticed in the past, is that students get factors and multiples confused. So multiples are many. Multiples are infinite. What does infinite mean?
It never ends.
It never ends. It goes on forever. I can count by 9s until the day that I die, because numbers go on forever. They are infinite. Multiples are many. I'm going to write that underneath here. Multiples, many. So when I'm talking about multiples, I want to think multiply. When I multiply something, numbers get what? Bigger or smaller? Bigger. When I'm multiplying, they get bigger. So my multiples of 12, I would count by 12s. It would be 12, 24, 36, 48, 60, and they go on and on and on. Okay, it doesn't just stop at 60. I could keep adding 12 forever because numbers don't stop. They're infinite. Start with the number and list the number times 2, then the number times 3, then the number times 4, etc. Meaning it just goes on and on and on. Now, when we talk about finding like a common multiple, usually when you're looking for things that are in common, you're looking at least 2 different things. I can't just find a common thing with one thing. I've got to have at least 2 different things to compare. So that means I would have 2 numbers that I would be listing multiples for, and I would list multiples until I come up with one that they have in common. Okay, and you'll see more of that tomorrow. All right, factors. Let's talk a little bit about factors. Factors are finite, means that it is a defined set. They end. They don't go on forever. There are just a limited number, okay? Factors are also listed in pairs. That says pairs. Sorry, that's hard to read. So factors will always be listed in pairs. Right here in my note, I'm going to say always come in pairs or have a match. Okay, so if I say that factors of 12 aren't just 1. Is 1 a factor of 12? Yes, but what is its match? 1 times what makes 12? 12. So 1 and 12 are a factor pair. Then 2 and 6 are a factor pair. And then 3 and 4 are a factor pair. So let's talk about factors of 6. Okay, remember, factors are pairs. So I want to list pairs. So 1 times 6 equals 6. We're going to use this T-chart. You're going to see this again tomorrow. So we're going to practice it with the T-chart. I'm going to list my factor pairs in a T-chart. 1 and 6 make 6. And then what makes, if I list 2 and what makes 6? 3. That's a typo right here. This should be a 3. Now, this is my T-chart. If I now take all of those factors in my T-chart and I list them out, I'm going to list them in order from least to greatest. So these are my listed factors. I took everything from this T-chart and I listed it out here. Notice I have an even number of factors. You should always have an even number of factors because factors come in what? Pairs. So this is what we call finite or a fixed set. Okay, so multiples are many, but factors are few. That's how I always remembered it. Factors are few, multiples are many. Okay, over here, the last part of our notes today, it's my multiples. It says the number multiplied on forever. It just goes on and on and on forever. So basically what I'm doing to list my multiples is I am skip counting. When I say skip counting, what do I mean? An example of that would be like 2, 4, 6, 8. You're skip counting. If I'm listing multiples of 3, I'm skip counting by 3s. 3, 6, 9, 12. If I'm listing multiples of 5, I'm skip counting by 5s. 5, 10, 15, 20, 25, and so on. Okay, multiples are many, factors are few.